Patrice. First off, can you tell us a bit about your research, your main research area, and how you began in the field?
Okay, so I'm Patrice Cani. I'm professor of molecular metabolism and nutrition at the University of Louvain in Brussels, Belgium. I'm also senior researcher from the National Funds for Scientific Research. And I have a background in dietetics and nutrition, physiology and metabolism. And I have to say that I really like to work on a specific field, which is the broad cardiometabolic disorders field. So obesity, diabetes, low-grade inflammation. And I started work in this field in 1997. And then I joined the lab where I am now in early 2000. So I start my research on gut microbiota early 2000s, almost 20 years ago. And I used to say that I'm scientifically born in the lab where the prebiotic concept was born when Professor Marcel Roberfoy and Glenn Gibson were the first to propose that we can change the microbiota composition and having a beneficial impact upon whole cells by using specific fermentable dietary fibers, namely at that time the inulin type fructans. And when I arrived in the lab, they observed that the rats that were fed with these type of fructans were leaner. And this is exactly what has been the triggering factor for my research, why they are leaner when they are eating this kind of fibers. And we discovered different routes of dialogue between the gut and the brain. So that was the really beginning of the gut-brain axis. And we found that, for instance, some hormones were highly produced when you change the microbiota composition. This is namely the GLP-1 and PYY, that very well-known gut peptides controlling appetite. And I have to say that was really the beginning of all this story on microbiota from my side.
That's amazing. Can I ask you, what is your best advice you would give to care for your microbiome?
Well, I should say nutrition, nutrition, and nutrition. Why 3 times the same word? This is because, in fact, this is the best and most powerful tool to have an impact on the microbiome, either in a good way or in a bad way. So it can have a very beneficial impact. When I'm saying that, this is because 15 years ago, we discovered that feeding mice and rats with a high-fat diet, mostly saturated fatty acids, was associated with a change in the gut microbiota composition. There were very few data at that period of time. It was mostly fibers that were studied, not really the nutrients in itself. And when I've seen this, I directly understood that it is not novel in itself. We know since many years that saturated fatty acids, the lack of fiber, can be associated with some metabolic disorders. But there we just pointed more specifically maybe one of the mechanisms by which some lack of fiber or high level of fatty acids, namely saturated, could be interesting to play with in this framework. So I should say this is not really rocket science. What I'm saying here is, if we want to change the microbiota, just think also about this Mediterranean diet. You increase fruits and vegetables, so more fibers, more polyphenols. You change the type of lipids, more polyunsaturated omega-3 fatty acids. And so there are very basic advices. But if now we look more carefully about this link with the microbiota, we really understand that the microbes, they are fed by our own diet also. And so if we want to take care about our microbiome, we have to take care about our dietary items, and so our food in itself.
Yeah, exactly. You are what you eat. What do you think is the most exciting aspect of the microbiome research frontier in your research area?
Well, I think that we have to compare the microbiome as a really early field. Some colleagues don't really like that I am saying when I'm saying this, because they think that we are really already deep in the knowledge. But I always try to compare this as the discovery of insulin. So 100 years ago, we knew that insulin was able to reduce the blood glucose. Today, we still have many other mechanisms that are not really well understood. How to change the insulin secretion, how to change insulin sensitivity, how to play with this just couple of glucose and insulin. For me, the microbiome is also something that is really novel. And we have to go deeper. We have to go deeper, just not having the simple association between some bacteria and diseases. One is increased, the other is decreased, and is correlated. We have to go to the causality. And this is the real challenge, to prove that there are real specific links between one or several microbes and their metabolites also. And then we will go deeper in the interpretation, and we will probably have more power to play with in specific tools. So I want to be really careful and try to say to the colleagues and all the people in the field that the microbiota is not the magic bullet in itself. And we have to understand exactly what is inside. So the challenges are there, trying to also isolate specific microbes, new bacteria, and try to see how they can play and dialogue with our own cells, but also together.
Yeah, I couldn't agree more. I think we're probably just at the surface at the moment and we need to go deeper. Could you tell me, what do you see as the greatest challenge in microbiome research?
Well, as I mentioned, for me, the microbiome must be seen as one part of the big puzzle of physiology and metabolism. We have to be careful and not saying that the microbiota is doing the job alone, of course, but we also have to think about that we only have one piece of the story, one snapshot. We are usually analyzing the microbiota from the feces. And for me, the biggest challenge will be to investigate the microbiota, really where its very specific work is done. That means at the luminal part, of course, but also at the mucosal part. So very close to the cells, and not only in the colon, but also in the upper part of the GI tract. So the big challenge will be to have a big picture from all the different dialogue, all the different molecules, and how hopefully the microbiota is really dialoguing. So trying to understand this dialogue, what is the language? What are the molecules? What are the mechanisms by which in the real life the microbiota is changing our health?
Yeah. So when do you think patients will see the benefit of the current microbiome research in mainstream medicine?
Well, I think it's already the case today.
Yeah.
I want to say, yes, they already benefit from the current microbiome research. If we just think about the impact of the diet on our microbiota, and the example that I like uses this famous Mediterranean diet, because there are many papers now showing this interaction, of course, with health, but also with the microbiota. And so we also know that we can play with some bacteria or yeast to reduce the risk of diarrhea upon an antibiotic treatment. So we have today already some benefits that are available. But if we want to go further and deeper in specific diseases, type 2 diabetes, neurodegenerative diseases, inflammatory bowel disease, we are still far from understanding all the picture and to have really one key target. Then we also have to play with specific bacteria. I like to play with one of my favorite, which is Akkermansia, of course. And this is not the magic bullet, but this is one of the examples that we bring from a simple observation in rodents and in humans, so correlation, to some causation, at least in rodents, and we are trying to move in humans. So I think that we will have in the future a panel of possibilities, but we already have some room to maneuver and to play with microbes, specifically if you select some dietary items, some food.
Yeah, great answer. Where do you see microbiome research being in 5 years?
This is a tough question because 5 years ago, I was not really thinking about the bloom of all these thousands and thousands of publications that we have today. This doesn't mean that we know exactly how it works. This is not the end of the story. But I think that in 5 years, we will probably have, if it is blooming as it is for the moment, we will have probably more details on the microbiota composition, the type of microbes. Probably uncultured bacteria will become cultured. So we will better understand how they are dialoguing together with our own host cells. And then maybe we will move towards this personalized medicine, including the personalized modification of the microbiota. In other words, you have a specific microbiota composition, you probably need this type of diet instead of this one, and you will be responder or non-responder to some drugs because you have a specific microbiota composition. Then you will fine-tune probably the use of that. In 5 years, I'm not saying that it will be for the patients. I think that it will be still at the level of the research, but we will go further in the understanding and maybe propose some tools.
Personalized nutrition, really, is it?
Yeah.
Yeah. So if you had unlimited resources, what scientific question related to the microbiome would you like to explore?
Well, I will probably try to isolate bacteria that have never been isolated before. So it's a great challenge because we know that almost 70% of the bacteria have never been cultured that are in our gut. It doesn't mean that they are not culturable, but we have to try to isolate them and to understand how they work. For that, we need large isolating programs. We do that in the lab on 1, 2, or 10 people, and then you have few culturomics bacteria, and then you try to play with. That is one of the future challenge if we have money that we have to do, that we have to start probably. Also, another one is to follow during the early life until aging the microbiota composition in different situations, trying to have, if it's possible, but we can dream, a real recording on what is happening in the gut. Let's imagine you have the possibility to record the different type of bacteria, their metabolites, what they are doing throughout the GI tract, and then you record that simply by a system that is at distance and dreaming. But that will give us a lot of information, and not only for one specific person, a healthy subject, but also in pathological situations. I like to dream. We will see if it is a matter of money or techniques. Usually we say that the money is not the problem, is until where we are able to put our mind and to say, I will do that, we will be able to do that. I will not do it myself, but I think and I hope that in the field some people will go really, really, really far from this, in this knowledge, I should say.
Okay, great. If you weren't a world-renowned research scientist, what would you be?
If I was not a research scientist, I would be a surgeon.
A surgeon, okay.
Yes, this is a very old dream. Like when I was a kid, I was seeing myself as a medical doctor, but surgeon. Because for me, the surgery was in my mind something really clear.
Yeah.
We know what we have to do if we want to reconstruct, to build something, to remove something that doesn't work perfectly. it was clear. There is no doubt. In fact, this is not the reality. We know, I know, but I still have this dream that I can try to help people and to solve problems, to save life. Why not? This is not yet with the field of research that I'm looking for the moment that I will really catch this dream. But yes, but I've really love to be this surgeon.
Well, I'd say you would have made a great surgeon.
Thank you.
So that wraps up today's interview. I'd like to thank you for your wonderful insights into the microbiome. Thank you, Patrice.
Thank you.